Hello, everyone. My name is Kevin Tarr. I'm an iOS engineer, and today is day 36 of algorithms in Swift. So today we're going to be dealing with binary representations of integers. Okay, so that is the 0, 1 numbers that we so infamously recognize computer code to be. But no, we're dealing with the bit representation of integers in memory, and basically trying to order them in an array. So we're trying to order numbers up to a certain number by the number of ones in their memory bit binary representation. Okay, so we've done problems like this where we've broken down, not exactly like this, but similar, where we've broken down numbers, integers, and gotten a binary representation and gotten data from it, or manipulated it somehow, or returned something from it. But this one is a bit different. This is ranked medium on LeetCode, and I think that this problem it's challenging if you aren't familiar with binary representations or you find them intimidating. But we could solve this problem in maybe 4 lines of code, if that. Probably less in the for loop, maybe 2 lines of code. But I think this is a good learning practice either way. So without further ado, let's begin. Okay, guys, so our problem states, given a non-negative integer number, which means a positive number, very obtuse for no reason, for every numbers I in a range of 0 to I to num, calculate the number of ones in a binary representation and return them as an array. Okay, so if you guys remember the binary ones video that we did a while ago, um, this should be fairly straightforward to understand. If not, basically every number in the integer range from 0 to integer max, 2 billion, negative 2 billion, positive 2 billion. But every number has a bit representation. There's a number of ones in this binary representation. Basically, we need to find the binary representation of every number up to the number argument in the function, and count how many ones there are in the binary representation, and then return that in order in an array. So we can use the string. We can convert the number into a string, um, get its radix equivalent, and then filter the string, count the number of ones, and add that to an array. So let's do that right now, okay? So let's create an array. Integers. We do for number and 0 num. Let binary ones, the binary ones count equal string number radix 2 dot filter element equal 1 dot count. Okay. Then array dot append binary ones count. And then return the array. Okay. So let's run this code really quickly, see if it works. Boom, worked. All right, so let's solve it. Let's knock it out the park. Home run. Yeah, let go. Bravo. So one's faster. Well, it uses less space than 77% of Swift submissions. I think that's pretty good. We could have been a bit faster, but this is still good, and it still solves a problem. But you see how simple this is, and how concise and brief this is. If you want to actually make it more readable, because I stuffed everything into one line, basically we could do this, we just break it up. Binary 1, a binary number. Let binary 1s equal binary number dot filter equal 1, and then let binary 1s count equal binary 1s dot count. And that should still give us a passable solution. But you see right here, it's more readable and it's more clear right now. Breaking it up like that does take more space because you're adding more constants and more data types. So instead of putting it in one line, you're adding more constants and data types. That takes up more space. So that's why we're using a bit more space, but still solves the problem. And this is more clear. So it's all about trade-offs of what you feel like is better. You want more readability and contrast for space, or do you want more space but less readability or less clearer readability? That's up to you, but this solves it, and so does the last solution. So guys, let me know what you think of the problem in the comments below. If you have any solutions to the problem yourself, please share. But for now, have a good day. Peace.